So, hi, my name is Muhammad Asradati bin Abu Bakar. So now I will explain one journal. So the title is Performance Improvement of Air-Cooled Refrigeration System by Using Evaporatively Cooled Air Condenser. So this application do because in certain place with very hot weather condition. So when very hot weather condition, the temperature increase and power consumption, air conditioner will be increased also. This application can affect to power consumption can be reduced to 20% and COP coefficient of performance can be improved 50% also. The basic principle air conditioning system have four components: compressor, condenser, expansion valve, and evaporator. So from the picture, we can see in room temperature, have hot air and cold air. So hot air will come in to internal unit and go to compressor, external fan coil, and expansion valve. So these three components inside condenser. So hot air will come out from condenser. So after condenser, the refrigerant come to internal unit and apply to inside building or room area.
Hi, my name is Hariharan. I'm going to explain the system design and experimental setup. An existing split air conditioner used in the experiments, consistent with the shape of condenser, a frame was built in fill-up by scaleless media pad with 5 centimeter thickness and installed in front of the air conditioner. Water circulation system including a small pump, a tank, and connecting the pipes were assumed on the system to inject water on the top of the media pad. Water circulation rate was constant for all tests. Hot ambient air passes over the evaporate media pad and get cooled, then passes over the condenser and finally exit from the back side of condenser. Uh, pressure The pressure in an inlet condenser and evaporate was measured refrigeration system before the temperature measured. The surface of tube was polished and removing any dust or rust, and then the thermocouple proper lead down the surface in the order reducing the thermal contact resistance between the thermocouple and probe and the tube surface. Thermal greases was used in the point of contact. Insulting tape was wrapped around the probe make sure good contact and also prevent any convection effect of ambient air or temperature reading. It was required to measure water consume rate due to evaporate in order compensation water. In water consume rate was measured by using the level of water variance in the tank during test period. Having the water level variation and the area of water tank, the volume consumed could be calculated also. Thank you.
Air conditioner methods of performance. Energy efficiency coefficient of performance (COP). This is a ratio useful heating or cooling provided to work required. A higher COP means higher efficiency. Second is cooling capacity, the measure of an air conditioning system's ability to remove heat from a room, thus making the room cooler. The third one, power consumption, the amount of electrical power the air conditioner consumes. This is directly related to the operating cost. Number four is airflow. This measures the volume of air and air on an air conditioner can move in a minute. Proper airflow is essential for efficient cooling and comfort. Number five is is refrigerant type. Different refrigerants have varying levels of efficiency and environmental impact. Common types include R410A, R22 being phased out due to environmental concerns, and newer, more eco-friendly options like R32. Lastly is thermostatic expansion valve, TXV, or electronic expansion valve, EEV. These components control the flow of refrigerant and improve efficiency by ensuring optimal superheat levels. Next part is the calculation of performance. This involves a formula for cooling capacity, work input, and energy efficiency ratio. For cooling capacity formula, which is Q equal to M multiply Cp and multiply delta T. Q is for cooling capacity, M for mass flow rate of the air, Cp is for specific heat capacity of air, and delta T is temperature difference between the return air and the supply air. For work input, W equal to Q divided by COP. W is work input, Q is cooling capacity, COP is coefficient of performance of the air conditioner. For energy efficiency ratio, EER, the formula is cooling capacity divided by power inputs. So this is the example of calculation. Given is the value of airflow rate, temperature difference, specific heat capacity, air density, and COP. Step 1 is to convert airflow rate to SI units and convert it to seconds. For step 2 is calculate the mass flow rate, which equal to 0.2264 kilogram per second. Step 3 is to calculate the cooling capacity. To convert delta T from Fahrenheit to Celsius, and then to insert in a Q formula. Step 4 is to calculate the work input power consumption. Work over Q divided by COP, which the answer is 433.24 watts. And the last step is to calculate the EER, which the value is 11.94. So for the cooling capacity, it is 1516.34 watts, and for work input is 433.24 watts, and EER is 11.94. These calculations give a clear understanding of the.
Hi, my name is Shafina, and my part is I am going to talk about the suggestion of system improvement from that we get from this journal. Okay, the experimental test shows that power consumption and performance of evaporatively cool air condenser improve significantly compared to the air-cooled condenser, and the improvement are increased as ambient temperature increase. It was found that increasing ambient air temperature decreases the coefficient of performance of air-cooled condenser considerably, but it has much less adverse effect on the performance of evaporatively cool air condenser. Power consumption can be decreased up to 20%, and total performance can be improved around 50%. Since the proposed system has better performance and also the cost of installing the system is very low, therefore its application in very hot weather condition is highly recommended. The potential of commercialization of the proposed system is very high, since it can be easily coupled to the existing system with low cost. Application of evaporatively cool air condenser will reduce the peak load of the power network in hot weather area because vapor compression air conditioner are usually responsible for the peak load. It also found that the performance of the system can be improved if a more efficient evaporating system is installed. I think that's all from me. Thank you.